Thank you, folks, for joining us. Our guest speaker has joined us as well. So my name is Chris Blask. I'm the chair of the ICS ISAC, and I'll run through a little bit of background on the center, and then we'll throw to Billy Rios, who's going to give us a talk on Tridium and Niagra. To go back to the beginning, this center was initially conceived in May of this year. A conversation was started with an expanding number of partners to look at whether this system should exist and whether the center should exist and the functions that it should provide. As we've looked at the ISAC matrix that was initially conceived and mandated in 1998 under a presidential directive and expanded under a Homeland Security presidential directive in 2003, we see centers that are aligned along industry vertical sector lines. So many of us are familiar with some of these, with the electric sector ISAC. There's also a financial sector ISAC that's been very active for a number of years. The REN, the Research Educational Network ISAC, has been working in the academic community for a number of years and providing a great deal of value. And there's also a number of horizontal ISACs in two basic categories. The National Council of ISACs and the Multi-State ISAC in different ways bundle these centers together. The National Council for national and international purposes, the Multi-State for state, local, tribal purposes. And the Supply Chain ISAC and the IT ISAC served as models for the ICS ISAC in that they deal with issues that are cross-sector. Everyone is affected by supply chain, everyone is affected by IT, and ICS, again, is one of those issues that works cross-sector. So we began a conversation expanding, including people like Sean Paul McGurk, who you're all familiar with, was the individual who put together what we have in the federal government with mechanisms like the ICS CERT and the NKIC and the ICS Joint Working Group. Gibbs Rebo at SAIC, again, who has a great deal of experience with this. And have been expanding this, individuals like Debbie, who's our community advisor, who introduced the session, Steve Mason, who's been working on membership, and Glenn Merrill, who has a great deal of experience in workforce development. One of the reasons the cross-sector functionality is needed both in the center and amongst our community as a whole is that all these systems are created. And while we're not able necessarily at this point, at least in the public domain, to look at cascading failures that have been caused by the failure of one individual sector, we can look at history to see how how individual problems have spread across sector. Those of us who are old enough to remember pagers might remember in 1998 when almost all the paging system went down. And this was due to a failure in space of a single satellite. So in the telecommunications sector, there was a failure. It brought down communications that had a great deal of impact on business. Credit card transactions, so the financial system was impacted. ATMs didn't work. And this was probably one of the first cases where we could look at the cascading failures costing human life. While there's not documentation on the cases, no doubt there is documentation that health workers were impacted, were hampered in doing their jobs, and that first responders were not able to be as effective. In 2001, there was, for those who recall, a lot of problems with the electrical grid, including 90-minute rolling blackouts. A study was done in May of that year forecasting the kind of impacts that we see on the screen here, that there was a significant impact to the gross domestic product of the state of California, the largest single economic bloc in the U.S., very specifically touching on $10 billion in losses in industrial, including manufacturing losses, job loss, household income, and an impact on oil and natural gas, so electricity, the electric sector impacting the petroleum sector, and the greater Western power grid reliability was impacted. As another example, only yesterday, while again this is very specifically not a cyber attack, not a cyber incident, but a failure of a natural gas pipeline hit the transportation sector yesterday in West Virginia, where for a day the interstate was brought down by a pipeline rupture. So we know these systems connect to each other, and in recent days and weeks, this conversation has been coming up an awful lot more. How we connect every system is dependent on every other system. This has been a topic we've all touched on in all of our conversations all along, and particularly over the last couple of years as this space has gotten more and more attention. There was a study done 10 years ago that lays this out very well. The URL is down here. We'll make these slides available to anybody who likes so you don't have to necessarily write that down. But looking at the dependencies inside organizations, inside facilities, and between facilities. You can't have electric power without water and without transportation. And as we look at the spaghetti diagram that connects all the utilities, it becomes quite clear that there is no isolation between sectors. In my commercial activities outside of the ICS ISAC, I've spent a lot of time this year, and particularly in recent months, working with nation states to look at how they address these issues on a broad scale. And starting from the top down in Yemen, for example, and in Qatar, I've been talking to the folks there, and there's two very different examples. In Qatar, they've done a very good job of addressing this, among the best in the world, and they have a small community with very advanced systems. In Yemen, they have a great deal of challenges and not a lot of systems, but the structure ends up being the same, that you need to look at all of the systems and how they interconnect. So this is one of the areas that the ICS ISAC is meant to act as one of the vehicles for addressing these issues. One of the focuses that we're trying to propagate through the activities of the center is to help people work through the differences between data, information, and knowledge. As everybody in this community knows, the legislation that's been pushed, that's been working its way through or not working its way through the U.S. federal government, works with information sharing. The name of the ISAC talks about information sharing. And I think it's important both functionally and legislatively for all of us to build mechanisms where we're very clear on what we're sharing and what the risks and liabilities therefore are. And in the context that we at the center talk about it, data is very specific atomic information, is syslog messages, event messages. Information is everything. So if you're running an oil facility, you're running a manufacturing facility, it's all of these points of data put together that describe your topology, that give your MAC addresses and IP addresses. It's important for us in the private sector, for us in the security community who understand these issues and the contingent issues that are related to them, to help to both put in place mechanisms so that we can use the knowledge from that information without necessarily exposing that information or sharing that information at all, particularly where it gets sensitive and acts as barriers. Those sensitivities act as barriers. And it's important for us to create these mechanisms, to create these means, so that those in the legislative branch here and abroad can build the regulatory structures and the legal structures necessary to allow us to fix the problems we're having. Most notably, they net down to the fact that if the U.S. infrastructure comes under attack during this call, we do not currently have the ability to necessarily detect that. We don't necessarily know whether or not, for example, 15% of electric utilities in the southeast states came under attack 5 seconds ago. This is one of those issues we will address. The need to do this is too strong to allow that to linger for long periods of time. So over the next 3, 5, 7 years, either those of us in the private sector will solve these issues, or the public sector will solve them for us. And that's not always good. So what we're leading up to is something that that I've been looking for since early 2006. As these years have gone by and we've connected more of the dots, more of the individuals, like those of us on the call here, amongst ourselves, we are starting to see the structure of what we refer to as the global knowledge network rising around us. And it works like this, where the facilities themselves at the lowest level, at the most fundamental level, begin to have the capability to have some situational awareness of their own industrial control systems, where they have the tools and techniques and technologies and processes to see what they have and see what it's doing. Then they start to create knowledge. As I touched on earlier, most facilities do not have the capabilities to detect whether or not they're under attack. This is obviously not a desirable situation for them at an individual level. As they develop these capabilities and are able to share, again, not specifically the information, maybe not even the identifying information of who they are, but the knowledge of the positive and negative things that have happened to them, they can share those with the growing constellation of knowledge-sharing centers, locally, nationally, and internationally, that have been evolving. Service providers play a large role in this. This is why the MSSPs, why the integrators both large and small, have a very particular role to play. Facilities are already sharing data and information, quite often full visibility with these service providers who are providing the consultation, providing the integration, quite often doing the operation of the facilities themselves. And where knowledge, whether directly or indirectly through service providers, can find its way to the constellation of private, public, and in cases like the ISAC's public-private centers. And whereas these centers can then communicate amongst themselves, then we'll be able to create that visibility necessary, so that the governor of Tennessee, where I live, for example, will be able to know with a certain level of certainty that his state is or is not under attack at a given point, where the President of the United States will be able to know this. And even more importantly, because all of us both live in an internationally and globally connected world, and quite often are international and global companies and organizations, where we as an international community will be able to share the knowledge to let us know what the status is. Through these sort of systems, I believe, create the environment where we can get beyond the disadvantages. It's cliche to say among information security circles that we don't hold all the cards, we don't even hold the best cards. But in reality, we own the infrastructure, where we have complete access and control over the infrastructure in as much as we're operating it directly, or as much as we're the white hats that are involved in the public or private sector in maintaining and controlling the facilities. The adversaries have to take individual opportunities where they can to find their way in and do things. I firmly believe that it is within our reach to get ahead of them. And real-time knowledge sharing is another functionality that the ICS ISAC is focusing on, building on developments that have happened in the world. The REN ISAC has created a structure called the Collective Intelligence Framework, providing real-time defenses among the educational institutions. And through that mechanism, through protocols and transports like STIX and TAXI that are being developed out there, we look to create functionality that looks something like this, where a knowledge record is created, whether it's a vulnerability, whether it's an active threat, whether it's best practice. That can be shared through a center and then shared through other appropriate centers, where those centers themselves can multiply that out in real time out to asset owners. Where if we're looking through an MSSP, where data and information are being shared directly between a facility and a knowledge center, where that knowledge can be applied to real-time protection. For example, the ICS ISAC is working with the NESCO TAC, another nonprofit private sector knowledge center, and the Southern States Energy Board to create a pilot program in the Southeast states. So we're specifically working with them and working with municipalities like the Columbus, Ohio, as mentioned earlier, so that if, for example, a live threat is found on port 47923, so something that shouldn't be seen on an industrial control network, that's something that can be a very simple monitoring rule put in place by an MSSP in this example, so that all of their facilities are aware of it. So whereas in the Southern States Energy Board example, we're looking to create a constellation where any individual facility experiences something, all other connected facilities end up being immune to it in real time. And to look at the iterative feedback loop value of this sort of process, where those facilities or their service providers can then take that knowledge, look into their history, look into the logs and the forensics they have in hand, and be able to create information for themselves for their tactical purposes, such as the first time this was seen was 18 months ago. It's been increasing over the last six months, the last 6 days. It's trending upwards and it's spiking, and it's spreading beyond water and power. Again, there's nothing I said there that's contentious to share among trusted circles, and that can be shared back through centers like the ISAC and back to other connected centers, where it can be reverberated and fed back in. Through mechanisms like this, we stand the possibility of creating the autoimmune systems that give our critical infrastructures the redundancy and the stability that are necessary to support both advanced cultures like ours and emerging cultures like we all hope to see in countries like Yemen. So the center has gone through this process to date. I've conceived in May. We're incorporated in June. through the support of the thoughts and interaction of a lot of the best folks in the industry, created a website and started pulling open source information and doing weekly updates on the website in August. We did a demonstration of a basic framework for the real-time knowledge sharing at the ICS JWG in Denver in October. Just last month, we've created an idea scale community forum for members. So those of you who are members, under the community tab, when you log in, there's an idea scale forum there. This is a mechanism that's already used by the White House and FEMA and so forth. So we have good confidence that it's appropriate for our uses. In December, we had our first monthly briefing call. Thank you very much for showing up. We'll be doing this every month with a guest speaker. And beginning next month, because of the work of Glenn Merrill and the Workforce Development Group, we'll begin offering internships. So we can work on so we can both accelerate the functionality of the center itself, as well as bring in the young people that we need to train up for if we're going to solve this thing as our engagement with our being the entire community, our engagement with all the players globally scale up. So a number of I can't thank on behalf of the center. I can't thank enough both those listed here, the organizations that have been registered actual active members, as well as the broader community that's supported the organization to date, and Debbie and everybody else who has volunteered their time and provided their expertise to get us to where we are. So with all of that, I'm going to turn the stage over to Billy Rios, who is going to give us a talk on Tridium Niagra. So Billy, I will make you presenter here, and the stage is yours. And Billy, we're not getting your audio. I see, okay. I see that you're on the telephone. So, Billy, I just sent you your audio pin, which you'll need to enter in on your handset and press pound.
Hello? Can everyone hear me?
We can now, yes.
Okay, perfect. Let me go ahead and start this guy here. Can everyone see this deck?
You're in.
Okay, perfect. I'm Billy Rios. I'm going to give a talk about Tridium Niagra. It's really just an ICS security case study. If I'm going to go a little quickly, but if you have questions or anything like that, feel free to just shoot me an email or get in contact with me any way you can, and I'll be happy to answer those. So, a little bit about me. I actually don't work in the ICS world. I kind of just do industrial control systems security research for fun. It's kind of a passion of mine. I've acquired a lot of different industrial control systems, components, PLCs, software, all sorts of stuff, hardware. I've been looking at these for the last 2 years or so. I'm also in the Air Force Reserve. That's where I actually got a lot of the operational experience with industrial control systems. We did many assessments over the last 5 years or so on industrial control systems for various DoD installations. So a lot of fun stuff. But my day job, I work at Google. I'm a tech lead for a security team. Basically, we do the frontline incident handling, incident response. I also did a lot of work with Google+. Previous to Google, I worked at Microsoft, where I was the security program manager for Internet Explorer, and I was also a release engineer for a lot of different products. So fun stuff. I've been associated with a couple of books. I'm a co-author for a book published by O'Reilly, a contributing author for Insight Cyber Warfare. I also contributed to the Virtual Battlefield. But most relevant to this is some of the ICS vulnerability research that myself and a colleague of mine, Terry McCorkle, we did over the last couple of years. If you go online and look at the ICS CERT advisories, that's the Industrial Control Systems Cyber Emergency Response Team, you'll see that we're publicly credited over 30 times for various vulnerabilities in industrial control systems, finding a bunch of bugs basically in the way these things work. And we also do vendor assistance. We help vendors basically fix their software or find bugs. But what a lot of folks don't know is that we've reported over 1,000 different issues, individual issues to DHS. And so they're just kind of mining their way through that, trying to get their arms around that and just kind of slowly tackling those problems. But specifically, we're going to talk about this issue. So a long time ago, we sent this exact message to the Department of Homeland Security. This is just a PGP encrypted message describing a vulnerability in the Tridium Niagra framework. And that's the time, well, when they responded to us, this was the case number that they had assigned to us. This is DHS had assigned this case number so we could track this because there's just so many different issues. What we didn't realize up until last week was the issues that we had reported, they were actually used in the wild. So someone had forwarded me this link. I guess the FBI had issued an unclassified alert, cyber alert, saying that someone had actually used the Tridium Niagra vulnerabilities that we had reported to DHS to access New Jersey companies' industrial control systems. I think it was their HVAC system. The advisory is a little bit vague on the details, but it seems like someone gained access to a company's HVAC system. These can be very important, especially if the HVAC system is managing something critical like a data center, or if the facility is like a medical facility or something like that. So, but I wanted to bring this up. I wanted to show you this. You can go to the webpage yourself and look at the advisory yourself if you'd like to. But I wanted to show you this because a lot of folks think that a lot of these industrial control system vulnerabilities are theoretical. So, you know, we'll report these and the advisory is released, and that's kind of the last that you hear of them. But I wanted to show this is actually a real-world example of a specific issue that we're going to talk about that was actually used somewhere in the wild by someone that probably shouldn't have used it. So these things are very real. They are being used. A lot of these exploits are very, very simple. They're very straightforward, and the exploitation of them is very reliable. So that, you know, the likelihood of these being exploited is actually pretty high. So if you have these systems, it's important that you understand what your attack surface is and what you need to defend. So specifically, we're going to talk about some issues that were patched in the Niagra AX framework 3.5 and 3.6. So all of these issues are patched. We had a lot of help from Tridium's parent organization, which is Honeywell, in basically getting these patches pushed out. Before they pushed them out to the public, myself and Terry McCorkle, we had a chance to look at these to make sure that the fix was robust. They do work. So if you are running Tridium Niagra, you should definitely download these security patches as soon as possible and install them on your installations, especially if you have an internet-facing deployment of Tridium Niagra, especially if you have an internet-facing deployment. So I want to talk a little bit about the timeline. I think it's very important to understand this because this is very indicative of the industrial control systems world and the vendors in general. They are getting a little bit better, but we're still having a hard time kind of getting the message through. So initially, we sent the email to DHS, the Industrial Control Systems CERT, on January 28th. So we described a bunch of vulnerabilities with great technical detail, which were forwarded on basically that day to the vendor. So on April 17th is actually when we first received the first acknowledgement saying, hey, yeah, we got your email, and these vulnerabilities look like, you know, they're the real deal. So that's an extraordinary amount of time to get a response, a simple email saying, yeah, we got your email, these things are real. I'm not sure why this is the case. This is Tridium responding to us. I don't know if they didn't have the security expertise to basically triage this. I don't know if they didn't understand the vulnerabilities or maybe they just didn't care. We're not sure. So, but what we do know is that it took many months for them to just simply acknowledge that the bugs were there. So I think maybe this is what they had seen when they first got the report, right? They just weren't happy. So, and I want to talk a little bit about the response because I think it's important to understand this. If you're working in the ICS world with ICS vendors, it can be a little slow moving. So initially the response was, hey, you know what, this is Tridium to us. Hey, you know what, you're right, this is bad. We need to fix these issues. And so our response to that was cool, right? And then later on, they actually changed their messaging and said, hey, wait, actually, we're not going to fix this. This is too hard to fix. It's going to cost too much in dev cycles. And this is kind of a design issue, so we don't want to fix this. And so we asked, hey, you know, why not? In fact, at this point, DSH got involved, DHS got involved, and they said, hey, you know what, you guys should really fix this. And when I say DHS, I actually mean the Director of Control System Security at DHS reached out personally and contacted these guys and said, hey, you know what, we looked at the threat landscape. It's pretty bad. The vulnerability is super prevalent, and the exploitation of it's very reliable. You guys should really consider a fix for this. So they later came on and said, hey, you know what, we'll fix it. And so our response is, hey, you know, that's a great thing. And then later, for some reason, they said, hey, we know we said we were going to fix this, but we're actually not going to fix this. And then they actually asked us, hey, you know what, we'd be really happy if you didn't tell anyone. So we couldn't do that, obviously. So one thing led to another. We actually ended up getting in contact with Tridium's parent organization, Honeywell, and 3 weeks after we initially contacted and reached out to them, this issue was fixed. By fixed, I mean a patch was pushed out. So working with the industrial control systems vendor, Tridium, it was very difficult. As you can see, months passed by before anything was done. As soon as we got to the right people at Honeywell, which was Tridium's parent organization, this thing was fixed in a matter of weeks because they understood the issue very well, they understood the vulnerability very well, and they understood what they had to do. So, but a little bit about the bugs. So in all total, we reported a lot of different bugs, but there's 3 issues that were very, very serious. So the first issue that we reported was that the sessions that are used to authenticate to the devices or the software, it's really weak. In fact, it was protected with about 9 bits of strength. So 9 bits equals about less than 1,000 different requests in order to basically brute force a session. So that's not very much. In fact, someone could probably do that in less than a minute if they really wanted to. So we also realized that the username and passwords are actually stored in the cookie values. So, and this is not good for a variety of reasons. So a lot of this communication happens over HTTP, and so that allows an attacker that's nearby you on the same network segment to simply just grab your password. That's not good. But this also means that for other different types of attacks that are more common, like let's say cross-site scripting, what this means is a simple bug like cross-site scripting could actually result in the loss of your username and password for various users on the Tridium Niagra framework. So that's not good either. So, and then we have the last issue, which we thought was the most important issue of all of them. And this is basically a privilege escalation bug. It was later reclassified to a directory traversal issue, but basically what you could do is make a single request to the Niagra installation and download the configuration file, which was not inside the web root. And that configuration file contained a variety of things. So if we want to look at what a configuration file looks like, this is what a configuration file looks like. It's simply an XML file that contains a lot of information about the installation that you're talking to, basically, that you're connecting to. So, but most importantly for us, from a security standpoint, this configuration file contained all the usernames and encoded passwords for every single user on that Tridium Niagra installation. So if someone were to be able to gain access to this configuration file, not only would they know what the device is being used for, they would also have the usernames for every single user on the device. They would also have basically the password for every single user on the device as well. So this configuration file that we're showing you right now is Tridium's demo installation configuration file. So when we first reported this issue to them, it took a while for them to understand the issue and respond to us. But initially, they actually didn't believe that this issue would work. They didn't believe the vulnerability actually existed. They didn't believe exploitation was actually possible or practical. So they asked for proof. We asked them to basically use the exploit against their demo instance that they had running on their own hardware that they had set up and configured, because that was one of the arguments that they had made. They said no real-world deployment of Tridium Niagra would ever be configured in a way to where this exploit would work. So we did this against our demo server with their permission, of course, and basically we emailed them their own configuration file, which was this file here, with their own usernames and passwords in the device. So it's important to understand the attack surface here. It's important to understand the issue. So well, obviously, at that point in time, Tridium didn't understand the issue, and it took something like this for them to understand. So now that we have this bug, we're also very interested in what Tridium is used for. So Tridium Niagra in particular. So we went to the website. We looked at what it was being used for, where it was being used. It's actually being used all over for a variety of different things. The Niagra AX software is actually a framework, and the framework is on a lot of different devices. Sometimes it's on there as an embedded software, and sometimes it's installed as a regular software on a web server. So, but we'll talk to you about the specific deployment that we were looking at. So this is Niagra's kind of vision for the world. And you can see this is basically from one of their slides, one of their marketing slides. What they basically want to do is unify this user experience. And so they want to be able to talk to a lot of different devices and make that seamless to the user. So when you take a look at their slides, they want to talk to a variety of different services, like card access. The card access, like when someone is going to gain access to your building and they badge in. That's the card access system. Niagra Framework actually talks to those devices. Video for security, obviously, or other types of video that you have. Intrusion monitoring, when someone kicks in a door or opens a door they're not supposed to. The HVAC systems, the lighting, they want to be able to talk to all these devices, and they've done that. So I'm sure as a security engineer, this is super dangerous, right? When you have a machine or a device that can talk to all these sensitive components that unifies that experience, from a security design perspective, it needs to be really good. And this is just a video of the first security engineer for Tridium, right? Probably didn't like the design very much. So, but a framework example, like this is how this thing works. So let's say a card access system. It's going to generate some event, like, hey, access granted zone 4, and basically it's going to talk to the Tridium device. Same with the video systems. They're going to talk to the Tridium device over HTTP. Maybe your intrusion or disarmament, maybe your intrusion detection systems, your physical intrusion detection systems, they're going to talk to Tridium over some legacy protocol, and Tridium is going to be okay with that. Your elevator systems, for example, when someone badges into an elevator and tries to get to a certain floor, there's a computer that basically deals with the authentication authorization behind the scenes. Tridium facilitates that decision making, and let's say that happens over XML. Your HVAC systems, for example, they're going to speak over something like BACnet, and that's a protocol that's very common with HVAC. And it's going to speak to the Tridium system, and the user is going to use the Tridium Niagra framework to basically administer and manage your HVAC system. Same with your lighting. So your lighting systems can be hooked up to a Tridium Niagra framework machine or device, and that's going to speak Modbus, so the user can just connect to one device and manage all your lighting from a centralized location. Same with energy, even billing. You know, if you run a large building where you have lots of tenants and you want to bill them or generate an invoice every month or something like that, Tridium Niagra can actually facilitate that. So it's very, very powerful software. They're very, very powerful devices. They have access to a lot of different things. And so, but I think what's important here is when someone, like, we have a lot of people ask us, like, hey, what's the risk here? You found these bugs in Tridium Niagra framework. What's the risk to me? The answer is we can't tell you. Right? Because this software can be configured in a variety of different ways and connect to a variety of different devices, anything from card access to tenant billing to energy to lighting, we can't tell you how you're using this software in your deployment. Now, what we do know is that it's very versatile, and we do know that this is probably a very valuable hopping point for an attacker that's looking to affect your industrial control systems on your network. What we can't tell you is how you deployed this. So what you'll need to do is take a look at where you have Tridium Niagra on your network and see what it's connected to and who's using it to manage what. So very important takeaway. So as far as the architecture, a very high-level architecture goes for Tridium, they have the Niagra AX server. This could be an embedded device. This could be a web server. This could be a standalone machine. It could be a variety of different things. They have a variety of different configurations. But there's also these workstations. And what happens is, for the workstations, what happens is, like, they have these applets, and the applets are basically the way that the communications occur between the workstation and the AX server. So there are obviously a lot of different bugs here. So there's communications between the workstation and the server. Sometimes that happens in the clear. Sometimes it happens in an insecure manner. There's also DOM interaction between the applet and the user's browser. So there's a lot of opportunity for, let's say, code execution vulnerabilities on the actual engineer's workstation, right, as opposed to the server. And there's tons of functionality that occurs on the client side. What I mean by the client side, what I really mean is the workstation. A lot of this stuff should actually be happening on the server side, but since they have these applets on the client side, they actually kind of offload a lot of this processing to the client when they probably shouldn't. Things like password hashing, encryption routines, building SQL statements to run on databases, and things like that. And so this is what a box looks like. This is what we have this machine right here, this device. This is a Tridium JACE 545. We actually have this device. This is the one that we're using to test against and to develop all our proof of concept exploits and such. So if you open the device, this is what it looks like on the inside. So as you can see, it's just basically a motherboard. There's a power supply. It's actually a power supply, power converter, not really a power supply, and a battery. So an important piece is if you're starting to look at some industrial control system stuff, especially from a vulnerability research perspective, a lot of these things don't come with power supplies. So if you look at this thing, it basically just has a power converter. And so a little bit of electrical knowledge is kind of necessary to begin working with these devices. Like what type of voltage does it take? What kind of type of amperage does it pull? What is it looking for? Can I connect it to AC or DC or anything like that? So this particular one requires about 110 volts, 60 hertz. So you can basically connect this into the wall, but we just had to create a kind of a makeshift power supply for this thing to make sure that everything was working and safe. So there's a bunch of other components on here as well. Probably one of the most important components is this little thing right there. That's an RJ45 jack. That is where this device connects to the Ethernet. It can connect to a hub, it can connect to a switch, or it can be connected directly to the internet. It doesn't matter. It speaks IP. There's a variety of things that are served from this interface here. It's got a built-in web server, and this is where if you wanted to interact with the device over HTTP, for example, or TCP, this is how you would do it. It's issued an IP address. It's built into the board. It's usually set by the manufacturer, but it can be changed. So another important piece with industrial control systems, this is over here. This is the RJ11 jack. What that means is this is where you would plug this into a telephone line, because that is a modem. So that's very much overlooked in a lot of deployments. A lot of folks maybe will scan the network and see if they have any of these devices online. They may not be enabled from an IP standpoint, but they may be enabled from a modem standpoint. What's actually very popular amongst the ICS world is to hook these modems up to some kind of cellular capability. So the vendor or the maintainer can actually just dial into this thing and start administering it remotely from their home office. They don't have to drive out to wherever this embedded device is. So these ports over here are COM ports. This is where you would connect this device to the physical device that's controlling. This is where you would connect it to your HVAC or your lighting systems or your elevators or anything like that. These are just a different type of COM ports here. The first COM ports I showed you, they're RS-232. These COM ports here are RS, I think, 485. So these are just where you connect to devices. This is where you'll find out what this device is being used for, whatever devices are connected via these serial ports here. There's also another connector to connect to IONNet, which is a popular protocol for industrial control systems. The whole point of this is just to show you that this is a very versatile box, right? It's basically a computer running inside of a industrial box, basically a still box. So when you order one of these, you'll get a shipping statement like this. This is the one that I have. And basically, they'll have a printed username and password on the device or on the invoice for you. The Tridium username, that is the basically administrator username for the device. And usually they have a really simple password. In fact, that's the default password for the Tridium account for most installations. That's not good. If you look at a typical deployment, it's going to look something like this. So all these devices you see in the center, those are all running Tridium Niagra AX framework on them, and they're connected to various devices inside of a building. So if you're in a Fortune 500, you have a corporate, if you have a corporate campus, there's probably a closet somewhere that has the same setup somewhere on your network as well. So how prevalent is this? So when we first took a look at how prevalent this was on the internet, we reported all these issues to DHS, of course. There's a lot of these out there. So last year when we took a look, we saw that there's about 12,500 in the United States. These are 12,500 installations running on port 80 or port 8080 or port 443, which is actually not the default. So there's probably a lot more out there. So, and as you can see, the response from places like Shodan, it gives you a lot of information about the specific version that's being run, the specific firmware that's being run, and exactly what it is that you're talking to. So, and here's just a closer screenshot of that. The server tag, it's very obvious that we're talking to a Niagra web server here. 1.1, that's a very old version. The Niagra released, of course, the version number on there as well. So, this is us running the same query a couple days ago, just to see what's changed between last year and this year. So if you take a look at what's available, you'll see that the number of Tridium devices on the internet has actually increased. This is not going down. I don't know if this is because of a lack of awareness or if these devices are just becoming more popular, but we see that Tridium, the instances of Tridium Niagra on the internet is actually increasing. So what types of places are running this thing? Well, if we take a look at some of the results that are kicked back to us from Shodan, we see that there's some place in the Comcast business IP, but there's also some place called Beck Superior Hybrids. If we look at what that is, that's basically a farm somewhere. So they have a Tridium Niagra installation that's basically facing the internet. I don't know what it's connected to or what it controls, but they probably don't even realize that their instance is connected to the internet facing. So, When you first connect to an instance, a Tridium instance from a workstation, like let's say a web browser, the first thing that's going to happen is it's going to ask you to download a Java applet. The applet is signed from Niagra AX, so that's good. But as everyone knows, Java carries its own challenges, right? So if you're going to be using these devices in your network and administering them from a web standpoint, that means your engineers are going to have Java running on their workstations. So when you establish the initial connection, what it's going to do is basically download one signed jar, and it's going to use that signed jar to download a lot of different jars. So, and once all the jars are downloaded, you'll see an interface that basically looks like this. It's very graphical. It's very easy to use. It's actually pretty neat. It's actually really impressive software. So this is also another screenshot of what you would see if you were managing, let's say, an HVAC system in your enterprise. You would see something like this. It's pretty robust. It's very intuitive. It's very easy to use. So what happens when you install that jar onto your machine, that Java jar? Well, basically what happens is that signed jar, because it's privileged, creates a directory called Niagra on your local machine. So on an engineering workstation, you'll have a directory called Niagra. Inside that Niagra directory, it'll create two more directories, one called credentials, one called WB applet. So inside the WB applet directory, it creates more directories like lib, licenses, modules, users, workbench. The one that we're most interested in is the modules one. The modules directory contains over 50 different jar files, or nearly 50 different jar files inside there. That's a lot of attack surface for the client. So here's a screenshot basically of some of the jar files that are downloaded locally to your machine when you connect to a Tridium Niagra installation. So they're nicely labeled, and they have the version number that's being run. So it's pretty neat. Inside the credentials directory is a hash of some credentials for the current user. So if anyone were to ever able to gain access to a specific directory, they would see the password hash that's stored locally. So when you go to a Tridium installation and you're interacting with the device or the embedded server or the web server, basically you'll see something like this. And so if you take a quick look, you see the domain name, which is cstoredemo.tridium.com, and then you'll see ORD. So ORD is actually a very powerful concept in the Tridium Niagra world. And ORD is actually an object resolution descriptor. And here's a quick description of what that means. But really what that means is it's a mapping between what your browser or the Java applet is sending to the server and the specific APIs and the functions that are getting executed on the actual device itself. So it's actually a very powerful concept. It makes it to where you're not actually really browsing to different things. You're actually kind of just interacting with various APIs. You're almost like a developer when you're interacting with the Tridium Niagra framework. In fact, these ORDs allow people to basically extend and build their own modules so they can interact in Tridium Niagra with ways that the vendor never actually envisioned. So here's some examples of what ORDs look like. This would not be in your address bar. Rather, this would be actually what's executed on the local device, on the embedded device or the embedded web server. So you would make a request via the web server. That request would get parsed, and on the devices, this is what's actually getting executed. So you can see there's a lot of different functionality here. But Niagra actually allows a way to list all the ORDs that are installed. Like I said before, some folks can actually extend on these things, build their own modules, and make the Tridium Niagra framework do things that was never intended to do. But if you want to see all the installed ORDs at any given time, you can actually just make this request to the device, and it'll actually list out all the ORDs that are installed. So just a quick recap. So when you make a request via a web page, what's happening is actually that URL is being parsed into a couple different sections, and those things are actually getting passed to the backend server. So here's me running the ordinal enumeration. So here's all the ORDs, all the modules that are installed on this particular device. This is the demo device from Tridium. So this is on the internet actually. So you can actually see every single module that's installed, whether it's basically a default module, whether it's a custom module that they wrote themselves, and you can actually see which scheme is associated, which functions are associated with that particular ordinal. Very important if you're looking at a Tridium Niagra installation, especially if you're looking at it from a vulnerability standpoint. So, and like I said before, these ordinals and modules they're extendable. So, and this is like, for example, a place that shows, hey, these are the types that it supports. This is basically the interface and the super type that it supports. So if you want to interact with this particular module, you can just build it to this specification essentially. So There's also a lot of basic default behavior that's enabled by these devices that's super dangerous. So these aren't considered vulnerabilities per se, but these are actually very dangerous if someone gains access to your Tridium Niagra installation. So for example, here's a quick way to look at what's standard out is kind of printing. So this is basically kind of like a debug console. So when the device needs to print something out, like a debug error or a log of some sort, basically this is how someone would read it. Usually this is only available to someone that's on the local machine, but as you can see, anyone can run this remotely against a Tridium Niagra installation. And if you look at the types of things that are being printed out, there are warnings and errors and messages, and they have like sensitive data like the path and which things are being served from and places that it's connecting to. So this is by design. These are not considered vulnerabilities. These are considered designs. So I doubt these things are ever going to go away. It's important to understand, if you do have a Tridium installation, it's important to understand that these things are out there, right? And here's just a quick screenshot of some of the stuff that's stored in standard out. There's also other things. For example, anyone that connects to a Tridium Niagra device can see who else is connected to it at any given moment, and also who connected to it in the past, how long they were connected to, and what their session basically looked like. So, and here's just an example of that, basically. Someone connecting to the Tridium device, when they connected, how long they were connected for, and et cetera, et cetera. Those are all by design features, right? Those aren't even considered vulnerabilities. So back to the vulnerabilities. So when we make a request like this, a file with a tilde mark like that or a mark like that and then config.bog, what actually happens here, right? So I think a lot of folks that do web application vulnerability assessment, they're very familiar with the directory traversal style attack. Usually they involve dots and slashes where you say dot, dot, slash to basically traverse out of the web root and grab a file that you're not supposed to grab. But in this case, it's a little bit different. So we knew that there was a directory traversal vulnerability here, but it was not a dot, dot, slash issue, right? It was with other control characters that we were using. But we also knew that this is basically a natural fit for any functionality which retrieves files from the file system of the server. We're most interested in retrieving files from the server. So we looked at the various ords and modules are installed by default, and so the file ord is an obvious selection for something like this. And so what we do is just say file, we have a special control character, and we say config.bog. What essentially happens here is that request gets handed off to an API inside javax.baha.file.bi file, which is basically default installed on every single Tridium Niagra installation in the world, right? So that character that we're using basically tells that API, the javax baha file bi file, that we're requesting a user absolute directory. That's the term that they're using. And by default, that user absolute directory is one directory below the web root. What's also convenient for the attacker is the config.bog file is typically stored in the user absolute directory. So when we make this request, we're actually making a request for a file that's never supposed to be served to a web page or to a remote user, and we're downloading that file. So the user absolute paths are stored under the user home directory, and that user home directory is actually identified by a different API called sys.getUser-home. So in this case, the user home directory is still the directory of the station database. So we can actually download the station database as well. But the config.bog file is actually the one file that kind of contains everything. So that's the one we targeted. We also enumerated a bunch of different paths. This is not a vulnerability. This is just useful information, especially if someone's doing, let's say, vulnerability research or trying to exploit a Tridium Niagra installation. The character is not the only special character that's respected by the framework. So, for example, you can have what's called an authority absolute, which is / specify the host name, and then directories that you want to take files from. There's also something that's called local absolute, and then there's something that's called system absolute, which is the actual absolute file path for the system itself, right? Then there's user absolute, which we already gave an example of. Then there's relative, and there's also something called relative with backup, which is where your / style directory traversal attacks would work. So I think Tridium has addressed most of these issues. But there still may be some flaws in their patch implementation. I don't know. We haven't looked at those things specifically yet. So, but if you want to see where all these paths are basically identified, you can look at an API called sys.getBahaHome, and that's going to tell you how all these things are basically created. So, once we've downloaded the config.bog file, that file is actually compressed. So if someone actually does this, they'll just get some blob of data. What we first need to do is uncompress that file, and once the file is uncompressed, you'll see that there's an XML file contained within it. And so we reported those vulnerabilities, but there's actually a lot of areas for further investigation. We're doing some of this further investigation, Terry McCorkle and I, but these are some of the areas we kind of told folks who asked what the attack surface probably looks like for a Tridium Niagra. So first off, the jars, there's about 50 jars on every single engineering workstation that uses Tridium Niagra. So these are the guys that manage your industrial control systems in your organization. So with that much attack surface, there's likely some code execution vulnerability inside those jars, or several, right? So there's a lot of very complex functionality built into them, like file downloading, a lot of socket connections back to the server, and things like that. And so it's just a lot of attack surface there. The client-side code generates a lot of stuff, like SQL and BQL statements that are eventually run on databases somewhere on the back end. So what this means is if we understand how that works and how the protocols are created and how the protocols are used, we can actually probably just create our own requests and start running arbitrary SQL and BQL on various databases or historians that you have on your back-end database, which would give us code execution on a server someplace inside your network. That's not good. So credentials for these things are stored in a lot of different locations. So we showed you where credentials are stored on the local file system for the engineer. We also showed you how the credentials are stored in the config.bog that's stored on the server. But there's credentials stored in a lot of different places. And a lot of times they're stored in an insecure manner. So they're stored in the cookie and all sorts of stuff. So gaining access to credentials for people who manage and administer Tridium Niagra, obviously a very bad thing. And the last piece is there's very complicated interactions with the server and devices, right? Like these things speak serial, a lot of times it's unauthenticated. And so if we can basically create or make the device issue requests or responses to things on the serial or the Modbus or the BACnet, that would be very bad as well, because we would basically be bypassing the device and just interacting directly with the ICS that's on your network, your elevators, your HVACs, your badging systems, and so on. So I know I went a little fast, but I wanted everyone to kind of get an understanding of how complicated these systems are, some of the research that we're doing, and how much research is left, because there's a lot, right? I also wanted to show that these vulnerabilities, they're not so like esoteric that no one really understands them and can't use them. They are actually really being used in the wild, as evidenced by the FBI advisory that was published this year. So, but I did also want to take a few minutes to answer any questions if anyone had any of those.
Absolutely. So if anyone wants to chime in, there's a question gadget in the GoToMeeting that a number of you have used already during our technical issues at the beginning, so feel free to pop those in. We can unmute you so you can talk directly. And while we're waiting for any of those, thank you, Billy, for, as always, an epic presentation. And talk to the the issues of the shared future that we're all part of. And as Billy has pointed out quite often, as we all know, this session on Tridium is not to pick them out of the crowd or to shame them particularly. These issues are shared. We're all sharing the same issues, whether we're vendors, whether we're all dealing with the vagaries of this science experiment we call web conferencing, or we're talking to our mute buttons. We're all in the same world. And the way we get ourselves into a better position is by knowledge sharing. The efforts that researchers like Billy and like Dale Peterson and Luigi and a number of others in white hats have been engaged with are both to individually point out failures that are out there in products and in deployments, but also to get the conversation going. We're not going to solve any of these issues by keeping them quiet. We're all familiar. I know that the audience we have here, the group we have on the phone, are folks that that have a lot of experience with this. We know that in the asset owner space, there's a strong inclination to stay quiet for a lot of reasons, for liability reasons. In the vendor space, as someone who's been a vendor for most of my life, I understand the desire to keep vulnerabilities from hitting the public, to both protect your reputations, your commercial interests, as well as protect your clients. So it's through finding ways to break our shells that we can talk amongst ourselves in trusted forums like the ICSG and like the one-on-one communications we all have at these conferences and amongst ourselves that we're trying to encourage through the ICS ISAC. And Leonard has a question. Billy, how do you pick a target to work on? So what's your methodology for deciding how with Tridium, for example, what was it that that jogged you to look at them?
Yeah, I think there's a couple different criteria. So, first off, some of this stuff is pretty expensive, and some of it's very difficult to get your hands on. And so a lot of times those things, because we're doing this part-time basically, a lot of times those things are kind of out of reach. And we try to find ways to basically gain access to those things. So a good example is, let's say we may not be able to purchase a PLC because it's too expensive, but we may be able to go somewhere and freely download the firmware for it. And then once we have the firmware, we can just reverse engineer the firmware and see if there's any vulnerabilities within it. So in the case of Tridium, we were actually talking to another researcher at S4 in Miami. This is why the interactions and sharing is so good. And that researcher's name is Arian Leverett. He basically had done some research on internet-facing industrial control systems. And basically he just had mapped the entire internet and basically mapped where industrial control systems were facing the internet in the entire world. And then he classified them. So he said, these are this is this component, this is that component. And when we were chatting, he was saying, hey, the most prevalent industrial control system that's facing the internet right now is this weird stuff called Tridium. And he said, I don't know what this stuff is, but it's literally everywhere. And so that kind of perked our interest, and Terry and I started looking into that because it's just so prevalent. And we found out that these are actually pretty sophisticated devices. And so there's a lot of attack surface. So we started with the things that we could get a hold of first, like, for example, the Java applets that are on the client side. You can actually audit those without having to do any kind of client-server interaction. You don't have to have a deployment set up. Later, we talked to some folks at Tridium. They pointed us to a demo instance, and we said, hey, we'd like to take a look at some of the security of that. And they said, yeah, go ahead, we don't care. And so we looked at some of their demo instances. And then later, we just found one, on on eBay, basically, that someone was trying to sell for a pretty decent price, and we just bought it. So now we have our own home lab basically set up. And over the last couple of years, we've acquired a lot of different pieces of hardware, a lot of different pieces of software. Just here and there, here and there. We don't have to spend very much money to get a hold of a lot of this stuff, but we're just opportunistic as to what we can look at. Yeah, that's a good question.
Yeah, exactly. And talking about Aaron's work as well with Shodan, leads us to Project Shine. And most of the folks here on the line are familiar with what Bob Rabinovsky and Jade Pronsky have done with a single server in the basement of Bob's house, where they compiled 500,000 exposed industrial systems. And one of the things the center has done is to work with another knowledge center with EnergySec and created the publicly accessible control system working group, which right now there's about 70 members in the private sector, representing a very good saturation in each of the important demographics, and where we're looking at how do we as a community perform the tasks necessary to do what we can to address the risk of large numbers of exposed systems. One of the classic connected systems that Aaron discovered with his first Shodan disclosure was the Louisiana Crime Lab, and raising any number of issues with that. That it was a building management system, it was an HVAC system, but when you went to the IP address that was disclosed, you saw a map of the floor plan of the facility, which causes security concerns beyond cyber. And a little bit of work, I did it myself when that first came out. You can geolocate that IP, find out that it actually is where it says it is. And these are issues we need to work through. And while the work done in the public sector, many of us know the folks at ICS CERT. They're all really, really good folks. They do what they can. The issue is larger than the U.S. government. The vast majority of these systems are owned by the private sector. The quantity of issues, both in the vulnerabilities embedded in the systems themselves, the number of connected systems, the number of organizations that aren't part of any part of this conversation. It's cliche to say it, but we're all the same folks. There's a couple hundred, maybe to be generous, a couple thousand people in the world who are involved in this. There are many, many millions of organizations, most of them very small, most of them outside of the U.S., that have no ability, have no awareness. So it's these conversations, the low-hanging fruit, what Billy just said about Tridium coming up because an individual researcher in Europe decided to spend some of his time enumerating some visible stuff, leads to assistance to the vendor. For somebody else, for Billy and Terry to take their time and look closely at those systems and provide feedback. If we're going to solve this problem, and I know everybody on this call, I know everybody in this industry is dead serious about it. This is more than a job. This is an adventure. If we're going to keep our cultures stable, we have to solve this. If we're going to solve this, we have to talk to each other. So each of us here, I know we wear multiple hats. We do multiple things. I believe very strongly in the ICS ISAC. I was actually a doubter at the beginning. This was not my idea. But I feel very strongly that this is a center that has an opportunity to do some good in this space. All of the conversations, as many conversations as we can possibly have amongst ourselves, will lead us to any solutions that we can possibly get to. And time is ticking. There's, the 2 years ago, I found myself often saying we've got 2 years to get to a certain point. I kind of think we have. It's not a great point, but we're expanding beyond some traditional bounds. I think what Bob and Jake have done with Project Shine indicates that. I think the willingness of a very large representative group to start dealing with the implications of Project Shine and spend some time over the long term with the PAX working group shows a strong indication that we're going in the right direction. And okay, so some comments have come in. We've gone over time. We started a little bit late. I apologize for any of the technical difficulties, and thank you all for staying through this. There's a question out there, will this video replay be available? Yes, it will. We'll take the video, we'll edit out the long quiet part of the minute and make it watchable so you can use that again. It will be posted on the ICS ISAC website, and members will be able to see it on the inside. We will probably make it available on the outside as well. We'll have to confirm everybody's comfort with that. And unless there are more questions at this point or comments from any of the other panelists, whether Debbie or Glenn, you'd like to put anything else out there that folks might like to hear, I will give a moment for folks to raise their hands on such things. And if not, I want to thank everyone for spending their time with us today. You all know how to reach me. The info at email address on the screen there will reach us as well for any comments or questions. I want to thank everybody who's been involved in getting the center to the point that it's at today, and thank you in advance for all the interactions we'll all have, both in the center and externally, solving all the world's problems and making a better place to be in the future. And wish you all a Merry Christmas, Happy Hanukkah, Happy New Year, and we'll talk to you all soon. And with that, I will conclude this call and see you all in the funny pages.
Yeah, thanks, Chris.
Thanks, Billy.